Welcome back to the series of network theory. In our last 4 classes, we have learned about mesh analysis and node analysis using KVL and KCL respectively, and we have simplified various types of electrical networks using those concepts. But the meshes or nodes that we used in those classes or to simplify those circuits, they were actually simple mesh or simple node. But in electrical networks, sometimes we may come across bigger mesh or bigger node, or we can say super mesh or super node to simplify electrical circuit, and they help us a lot in simplification. So we should have a proper knowledge about super mesh and super node. In today's class, I will be discussing about super mesh, and in the next class, I will be discussing about super node. So first we have to know that what a super mesh is. A super mesh is a concept of a bigger mesh when we have a current source between two meshes.
Let's take this example. Here we have an electrical network. In that network, we want to find out the current value through this 2 ohm resistor. That means through this resistor. Now we have two methods. One is mesh analysis, another one is node analysis. Now if we analyze this circuit, now we can see that here it forms one loop or mesh, and this part forms another loop. So in this circuit, we can form two meshes or two loops. But if we analyze the nodes, then we can find that here we have one principal node, and here we have another node that can be connected to ground, so that can be taken as a reference node. So this principal node can be taken as a reference node. So only we have one principal node here. That means the number of meshes is more than the number of nodes. So one way to simplify this circuit is we can easily apply node analysis method. Now if we suppose apply node analysis method, then here we will assume a voltage a potential of this node, and we will apply KCL. So easily we can simplify this circuit. So current, if we assume that the current is leaving this node through this path, and the current direction of this current source is already given, and for this branch also, if we assume that the current is leaving, so what will be, and now if we apply KCL, then it will be all the summation of all the outgoing currents will be equal to summation of all the incoming currents. Now this, if we find out the current value which is leaving this node through this path, the current value will be V minus the voltage of this voltage source, and this is the positive terminal, so this value will be subtracted, divided by 1, and the another current which is leaving through this path, the outgoing current, that is V by 2, and this is incoming current. So the summation of these two outgoing currents will be equal to the incoming current, which is 2. Now if we simplify this, it will be 2V minus 20 plus V, and that will be equal to 4. So we can write 3V will be equal to 24, or we can say V will be 24 divided by 3, so it will be 8 volt. And our requirement is to find out the current flowing through this 2 ohm resistor. So easily we can find out the current value. The current will be V minus 0 divided by 2, so it will be 8 by 2, which is 4 ampere. So this is one way how we can find out. But if we want to learn the concept of super mesh from this circuit, so here we have to apply mesh analysis method. Now if we analyze this circuit, as we can see here, we have one mesh. So if we assume that the current which is flowing in this mesh is this I1, and this is flowing in clockwise direction, and in the other mesh the current which is flowing is this, and the current value is I2, and this is also flowing in the clockwise direction. Now if the concept that we have already applied in other classes to simplify the other networks, from that concept if we apply, if we simplify this circuit, then we have to apply KVL in this loop separately, and also we have to apply KVL in this loop or mesh separately. Now since we have a current source here, so what we have to do is we have to assume a voltage drop across this current source value. Current is flowing up in this branch, so we can take this way that the this is the positive terminal, and this is, if we assume this way, the voltage is this. If we assume the polarity of this voltage value opposite, then also finally we will get the same equation and same result out of this circuit. Now, after assuming this voltage value across this current source, if we apply the concept of KVL in this loop, what equation we will be getting is, suppose if we start traversing this loop from this point, then we are traversing this voltage source from negative terminal to positive terminal. So if we take that value as negative value, so minus 10, then through this 1 ohm the voltage drop will be IR. So I is I1 and R is 1 ohm, so it will be plus 1 into I1, and then the voltage value, that is negative, so it will be minus V, and then through this 4 ohm resistor it will be plus 4, and the net current is I1 minus I2. So I1 minus I2, and that will be equal to 0. This is our first equation that we will be getting after applying the concept of KVL in the first loop. Now in the second loop, if we apply the concept of KVL and if we start our journey from any point, suppose if you are starting from this point, then the equation that we will be getting is 2 into I2, which will be positive. We are going by the direction of this current, so it will be 2I2 plus the voltage, the drop across this 4 ohm resistor. So with respect to second loop, it will be 4, and then the net current, which is I2 minus I1, and then the voltage drop across this current source, which is plus V, and that will be equal to 0. So this is our second equation. So it can be written or rearranged this way: 2I2 minus 4 I1 minus I2 plus V, that is equal to 0. I have taken minus I1 minus 1 common from this term. So minus 4 I1 minus I2. Now if I further rearrange the terms from the second equation, then it can be written like 2I2 minus 1. If I take common, then it will be my V, then plus minus here, minus minus plus V, then it will be plus 4 I1 minus I2, and then that will be equal to 0. Now one thing which can be noticed from these two equations is this plus 4 into I1 minus I2 minus V, this factor or this term is common between these two equations. So what we can do is, from here we can simply replace this term in this equation. So if I take 4 into I1 minus I2 minus V, that value if we further rearrange, then it will be equal to 2I2. So this value 4 into I1 minus I2 minus V, which is equal to 2I2, if we replace in this equation, then it will be minus 10 plus I1, and then we can easily write here 2I2, which is equal to 0. So it will be I1 plus 2I2, and that will be equal to 10. So this is our equation that we are getting by assuming a voltage drop across this current source. Now the same equation we can obtain from the concept of supermesh. Now here we have, as you can see, where we have a current source between two meshes. So in an electrical circuit, wherever we will have a current source between two meshes, there we will apply the concept of supermesh. And what we will do is, we will simply discard that current source and we will form a bigger mesh. So it will look like this when we will assume that as if there is, the current source is not there. So we will just open that path, and when we will remove this current source or discard this current source, so no current will flow through this resistor also. So in total, this current source along with this resistor which is in series, they will be removed from that path. It will be assumed that as if it is not there, and that way it will form a bigger loop or bigger mesh. So that is the concept of super mesh. Now one thing which will be noted here, that super mesh does not produce any extra current. So whatever currents we have assumed for those individual loops or meshes, with those current values we will form the equation by applying the concept of super mesh. Now here in this super mesh, what are the components that we see here is 10 volt voltage source, and then we have two resistors, 1 ohm and 2 ohm. And originally in the circuit, the currents that we assumed was through 10 volt and this 1 ohm resistor, I1 current was flowing. And that means through 10 ohm and 10 volt and 1 ohm resistor, this I1 current will be flowing, and through this 2 ohm resistor, I2 current was flowing in our original circuit. So these two current values will be taken while applying the concept of supermesh and forming an equation. Now, if we apply the concept of, or if we apply KVL here, and if we start our journey from any point, suppose from here, then it will be minus 10, since we are traversing from negative to positive terminal. If we assume that as minus, then minus 10, and then 1 into I1. And then if when we'll traverse through this register, then it will be 2 into I2. So it will be 2 into I2, and that will be equal to 0. So finally the equation that we will be getting is I1 plus 2I2, that is equal to 10. So this is our first equation. So we can easily notice here that the equation here that we are forming here by applying the concept of supermesh, this is exactly equal to same as the equation that we have already formed when we assume that a voltage value across that current source. So here we can find out, or we can form this equation easily with less time. So this is the advantage of applying the concept of supermesh. Now in this equation, as we can see, there are two variables. So we have to find out I1 and I2. So we cannot find out by the help of one equation. So we need another equation. To have another equation, we have to go back to the actual circuit, and we have to apply a KCL at this node, where we have this current which is flowing in this direction. So with respect to this node, we can say the current is entering. This is the I2 current, which we assumed in the original circuit in the second loop. So if we go by the direction of that current, so with respect to this node, the current is entering. And now if we go by the direction of the current of the first loop, then we can see that the current is leaving this node. And what is the current value through this path or through this branch is 2 ampere, which is the current value of this current source, and this is flowing upward. So that means with respect to that direction, this 2 ampere current is leaving this node. So if we apply KCL at this node, what equation we will be getting is this two, this is one incoming current and these two are outgoing currents. So here it will be summation of all the incoming currents, which is I2, and summation that will be equal to summation of all the outgoing currents. So I1 plus 2. So that means the second equation will be I1 minus I2, and that will be equal to minus 2. This is our second equation. So whenever we will be applying the concept of supermesh, the second equation we will get from the concept of, or after applying the concept of KCL, and that will apply at the node in that branch where we have the current source. Now the next job is to simplify these two equations and to find out the value of I1 and I2. So first equation what we obtained is I1 plus 2I2, and that was equal to 10, and I1 minus I2, that is equal to minus 2. Now if we multiply this equation by 2, then it will be 2I1 minus 2I2, and that will be equal to, here we have minus 2, so it will be minus 4. So if we solve this, then it will be 3I1, which will be equal to 6. So I1 will be equal to nothing but 2 ampere. But our requirement was to find out the current value through this 2 ohm resistor. So we need to have the value of I2. So I2 can be easily found out when we already have I1. So I2 will be, the second equation was I1 plus 2. So I2 will be I1 plus 2, that means 2 plus 2. So it will be 4 ampere. So current that is flowing through this 2 ohm resistor is 4 ampere, that we have already found out by applying the concept of node analysis. But since this time we want to learn the concept of supermesh, so we applied mesh analysis and we have obtained the same value. Now we will apply the concept of mesh, supermesh again in this electrical network. Now in this network, what we want to find out is current value, again current value through this 2 ohm resistor. So this is the 2 ohm resistor through which we have to find out the current value. Now if we analyze this circuit, we can see that here we have one mesh here, one mesh here, another mesh here. So we have three meshes, and we have one principal node here, then one node here, one node here, and one node here. So we have to, in total we have four nodes, principal nodes, and among those four nodes one will be connected to the ground, so that will be taken as a reference node. So we are left with three principal nodes. So here we have three meshes and three principal nodes, so either one we can apply. Now suppose if we want to apply the concept of mesh analysis, now here what we have to, in the beginning or at the first step, what we have to do is we have to first assume the current values, individual current values in those individual loops. So in the first loop, if we assume that this is the current I1 which is flowing in the clockwise direction, and this is the current value in the second loop I2 which is flowing again in the clockwise direction, and this is the current value I3 in the third loop, and that is flowing again in the clockwise direction. Now what we can see is here that we have a current source between these two meshes, and again there is a current source between these two meshes. Here we can apply the concept of super mesh. So what we have to do is we have to assume that as if this current source is not there, so we have to discard that, or we have to remove this current source by opening this path, and similarly that is applicable for this current source also. Now if we remove this current source from this path, so it will be discontinuous and it will be open, this path. And also if we remove this current source, then this path will be also this path will be it will work like an open circuit. Now if we remove these two current sources, then through this resistor no current will be flowing, so this will also not work. I mean, this will not have any existence in that path alone. So what in the super mesh, what we will have is we will not have these three components, rather we will have the this four resistors and this voltage source that we have in the outer periphery of that circuit. So all these five components will form a super mesh. Now we will easily apply the concept of KVL here in that mesh or super mesh. But here again we have to keep in mind that super mesh will not produce any extra current. So when we will be applying the concept of KVL, we will go by the current that we have already assumed for those individual loops. So through this 4 ohm and this 1 ohm resistor, the current that we assumed was I1 in this direction. Through this 3 ohm and 1 ohm, the current that we assumed was I2, and that was in this direction. And through this 10-volt voltage source, the current that we assumed was I3, and that was in this direction. Now if we apply the concept of KVL, if we suppose start our journey from this point, then it will be 3 into I2, then plus I2, then we have this 4 ohm and 1 ohm resistor, and for that the current value is I1. So it will be 4I1 plus I1, and then we have this voltage source which is the value is 10 volt, and we are traversing this time from positive terminal to negative terminal. So it will be 10, and that will be equal to 0. So if we rearrange the terms, it will be 5I1 plus 4I2, and that is equal to minus 10. So this will be our first equation. Now again we can see here that in this equation we have two variables, I1 and I2, and we cannot simplify without having any other equation that involves I1 and I2. So what we have to do is we have to form another equation that involves I1 and I2. So for that we will be going back to the original circuit, and we will apply the concept of KCL or node analysis. Now if we see this node, now here at this node we can see that this I1 current and I2 current, these two are associated. So if we apply KCL, then if we go by the direction of this current, then it is flowing in this direction through this 4 ohm resistor. So with respect to this node, the current I1 is leaving this node, and if we go by the direction of this I2 current, then it is flowing through 1 ohm resistor upward. So with respect to this node, the I2 is incoming current, and already the current direction of this current source is given, and that is leaving, and that value is 1 ampere. So if we apply the concept of node analysis at this node, if we apply KCL, then the equation that we will be getting from here is the summation of all the incoming currents is only one, and that is I2. It will be equal to summation of all the outgoing currents. So outgoing currents are I1 and 1, so it will be I1 plus 1. Now if we rearrange the terms, it will be I1 minus I2, and that will be equal to minus 1. So this is our second equation. Now in this in two equations we have I1 and I2, so easily we can find out the values of I1 and I2. What we have to do is, if we suppose multiply this equation by 5, then the new equation will be 5I1 minus 5I2, and that will be equal to minus 5. The first equation was 5I1 plus 4I2, and that was equal to minus 10. So if we simplify this two, then it will be, so I1 will cancel each other, and from here we can have the variable. So it will be 9I2, and that will be equal to 5. So we can say I2 will be equal to minus 5 by 9 ampere. So we have obtained the value of I2, but finally what we want to find out is the current through this 2 ohm resistor, and I1 and I3, these two currents are associated with this 2 ohm resistor. So from here we can find out the value of I1 easily. I1 is equal to minus 1 plus I2 from the second equation. So I1 will be equal to minus 1 minus 5 by 9. So it will be minus 14 by 9 ampere. So I1 and I2 we have already obtained. Only thing that we have to obtain is the value of I3, and that value I3 can be found out easily by applying KCL at another node. Now if we focus on at this node, say suppose node B, here we can see this I3 and I2 currents are associated with this node. So if we analyze the direction, then I2, as per our assumption, I2 was flowing in this direction through 3 ohm. So with respect to this node, I2 is leaving this node, and if we go by the direction of I3 that we assume, then the direction of I3 is this, and with respect to this node it is incoming current, and also the current value for this current source and its direction is given, and that is leaving with respect to this node. So at this node, at node B, if we apply KCL, then the equation will be summation of all the incoming currents will be equal to summation of all the outgoing currents. So the equation will be I3 will be equal to I2 plus 2. Now we have already found out the value of I2, which is minus 5 by 9. So easily we can find out the value of I3, that will be minus 5. It will be 18 divided by 9. So it will be 13 by 9 ampere. So what was required was to find out the current value through this 2 ohm resistor. Now we have found out the individual current values I1, I2 and I3. But if we see the through 2 ohm resistor, the current which are associated is I3 and I1. The value of I3 is 13 by 9, and with respect to this node, the current is flowing up, and the value of I1 that we have found out, that is minus 14 by 9, and as per our assumption the current was flowing downwards direction through this 2 ohm resistor as per our assumption, and that value we have found out as minus 14 by 9. That means actually this I1 current through this 2 ohm resistor is flowing up, so that will be plus 14 by 9. So if we want to find out the current value through that 2 ohm resistor, then it will be the summation of these two currents, 13 by 9 and 14 by 9. So it will be 27 by 9, and that will be 3 ampere. This is one way we can find out, or else if we write this way, that current through 2 ohm resistor, that will be with respect to this current directions through 2 ohm, what is the net current? That is I3 minus I1. So this way also we can find out I3 value is 13 by 9 and minus I1. So 1. Now I1 itself is negative, that is minus 14 by 9. So we can write this way, 13 by 9 minus of minus 14 by 9. So finally it will be again 27 by 9, that will be equal to 3 amp. So the current value through this 2 ohm resistor is 3 ampere. So this way we can apply the concept of super mesh and we can find out the expected parameter. So this is the end of this class.